All right, in this video, we're going to work through the following example where we verify the identity. The identity is cosine divided by the quantity 1 plus sine x equals secant x minus tangent x. Okay, so generally speaking, you want to start over on the more complicated side. That's probably this side over here, cosine x over 1 plus sine x. You could start on this side by changing to sines and cosines if you wanted to, but somewhere along the line in this particular problem, right, then what we'll have to do is sort of a tricky thing that we haven't really given an example of yet. And so the thing is you kind of want to get rid of that 1 plus sine x in the bottom part of this fraction over here. So this 1 plus sine x, we want that to go away. And there's really, because obviously it's not there in the, over on the right-hand side, that 1 plus sine x is not there. So there's no real obvious way to get rid of that. So I'm just going to show you the trick right here in order to do that. And so what you want to do is to multiply by 1, since this is 1 plus sine x, you want to multiply that by 1 minus sine x, okay? So with the opposite sign here. If it were 1 minus sine x, you would multiply by 1 plus sine x, okay? And I'll show you, work through the steps, but you'll see in the steps that will get rid of the fact that this is 1 plus sine x, and we'll make it so that there's only one term in the bottom. And by term, I mean something that's separated by addition or subtraction. It's just a lot easier to deal with that if it's up in the upper part of the numerator part of the fraction, okay? So I'm going to, again, this is not an obvious trick, so that's the purpose of this video, to show you how this goes, okay? So I'm going to multiply the bottom by 1 minus sine x, and that will make this only one term in the bottom. Obviously, in math, you can't just multiply by whatever you feel like, wherever you feel like it. It has to make sense mathematically. And so what we've got to do is to also multiply the top by that same expression as well to keep everything balanced out, right? If you take a fraction and you multiply the top and bottom by different numbers, well, that's going to change the value of that fraction, okay? All right, so that's the trick. All right, so on top, I'm going to go ahead and multiply these two fractions out. On top, what I want to do, right, I have cosine x times 1 minus sine x. That's going to have to be distributed. I'm going to have to multiply cosine x times 1. I'm going to have to multiply cosine x times sine x there, right? So when I do that, on the top part of the fraction, cosine x times 1 is cosine x. Cosine x times minus sine x will be minus sine x cosine x. All right, so that's what I get on the top when I multiply those things out. On the bottom, I have two binomials, okay? So two two-term expressions here, 1 plus sine x, 1 minus sine x. That has to be FOILed out, right? Or, there's alternative methods. But so I would do first times first. 1 times 1 is 1. All right, then outer 1 times minus sine x is minus sine x. Inner sine x times 1 is sine x. And last times last, sine x times minus sine x is minus sine squared x. Okay. All right. So next up, right, is to do some simplifying. So on the top part of the fraction, there's really no simplifying that I want to do. I just kind of want to leave it like it is for the time being. But on the bottom part of this fraction, there are definitely some things that I want to do. Okay. First off, on the bottom part, I have minus 1 sine x plus positive 1 sine x. So these are going to cancel each other out, right? And so that's going to make the bottom part simpler. All right, so on the bottom part, that is going to be 1 minus sine squared x. Okay. All right, so when I do that, 1 minus sine squared x, right, that looks an awful lot like this identity, right? Sine squared plus cosine squared x equals 1, except that that's this identity with the sine squared subtracted from both sides, okay? So I'm going to do that separately. All right, so if I subtract sine squared from both sides of this identity, over on the left-hand side, I would get cosine squared x. And over here, I get 1 minus sine squared x, okay? Now, some people at this point will say to me, hey, wait a second, you just told us not to do what you're doing, right? In the introduction to verifying identities, you said don't add or subtract, multiply or divide from both sides of the equation that you're trying to verify. And that's absolutely true, right? But I'm not trying to verify this identity. This identity is a known identity. It's been verified, right? This one is true 100%, right? And so it's also true that this is an identity as well, right? I can rearrange identities that I already know. The identity that you're trying to verify, right? This one, don't do that, okay? You're not trying to solve this one. You're trying to verify it, okay? So just on the ones that you're trying to verify, right, like this one, then stick to working on one side at a time, okay? On equations that you know to already be identities, right, then you can rearrange them and shuffle them around, you generally by adding or subtracting from both sides, okay? And so that's what we're doing here. So we know that 1 minus sine squared is now equal to cosine squared. So what I'm going to do is go replace that down here. All right, so I have cosine x minus sine x cosine x. That is all over cosine squared x. Okay, so that is essentially what we were trying to accomplish here by doing this trick. You can't really split up a fraction over the denominator, over terms in the denominator. All right, it just doesn't work that way. So the fact that this was 1 plus sine x kind of made things, there was really no other way to remove this because it's obviously not over here on the right hand side, okay? So so what I did, right, was this trick. I multiplied by the conjugate, so to speak, right? Same parts but different sign on 1 plus sine x. And that gave me this 1 minus sine squared x, which I know then I can use the identity, the fundamental identity, to change this to cosine squared. So now there's only one term here. It's not cosine squared x plus something else. It's just cosine squared x, and that makes it a lot easier to do what we need to do in the next step, okay? All right, I haven't been carrying down the right-hand side over here because I knew I was going to run out of room on my iPad here. So I'm just going to move everything up to here. So I'm just drawing this line so you'll know, hey, this is, I'm not I'm not working with this side. I'm just carrying this stuff up here. Okay. Okay, so what I'm going to do is, now that I've got this just cosine squared in the bottom, I can split up the terms in the numerator over that term down there. So over the term in the denominator. So I have cosine x over cosine squared x minus sine x times cosine x all over cosine squared x. All right, now you may say, well, what did you just do right there? Well, what I did was, right, I split up this fraction over the denominator. If you just think about how adding fractions works, right, if I want to, or subtracting fractions, if I want to subtract two fractions that have a common denominator, like these two, all I have to do is combine the numerators. So that would be cosine x minus sine x over cosine x, which is what I have here, over the same denominator here. All right, so I split up those terms over the common denominator. And a lot of times you won't see that. Normally you're going the other way, right? Normally you have two fractions that you want to subtract and you combine them into a single fraction. But here we went the reverse direction, right? Okay, and so now what I've got when I do that is I've got some common factors between the numerator and denominator here, right? Here I have cosine x, here I have cosine squared x, right? Which is basically cosine x times cosine x, all right? So what that means is I can cancel out that common factor of cosine x in this fraction here. So cosine x goes into itself once. Cosine x goes into cosine squared x one time, right? So that's going to leave me with 1 on top and 1 cosine x on the bottom, one factor of cosine x on the bottom. All right? So I had 1 factor of cosine x on the bottom, 2 on the top, 2 on the bottom. So I canceled that 1 on the top with 1 on the bottom. That leaves me with just a 1 in the numerator and 1 factor of cosine x in the bottom. And I'm going to do the same thing over here. Here again, I have a common factor of cosine between the numerator and denominator. I have 1 factor of cosine x in the numerator, 2 in the denominator, right? So I can cancel that 1 cosine x up here, right? Cosine x goes into itself one time, and I can cancel one of those factors of cosine x in the bottom. So that's going to leave me with sine x times 1 on top, which is just sine x. And on the bottom, it's going to leave me with cosine x. Okay, and so you can see that's pretty simple. You could see I could put that as 1 minus sine x over cosine x if I wanted to, but that's not really what I want, right? I want to make it match this right-hand side over here. And the right-hand side, I have secant minus tangent. So you can see, using the reciprocal identities 1 over and quotient identities 1 over cosine x is exactly the same as secant x. And then sine x over cosine x is exactly the same as tan x, right, using the quotient identities. So these identities here, 1 over cosine is secant, sine over cosine is tangent. Okay, and that's exactly what I've got over on the right-hand side. So this is a tricky one. Once you've seen that trick, though, then if you have 1 plus sine x or 1 minus sine x in the bottom, then that is a trick that, or even with cosines as well, 1 plus cosine or 1 minus cosine, that's a trick that you might want to take advantage of in certain instances.